Hello everyone, my name is Devashish Roy. I'm the Senior Network Analyst at the Indian Cybersecurity Solutions, and today I welcome you all to this special webinar that is the BGP Fundamentals and Route Advertisement. So today we are going to discuss about the BGP Border Gateway Protocol, that is the Internet Backbone Protocol. Every ISP depends on this Border Gateway Protocol. So what is the specialty about this BGP and what are the features and how to advertise routes in the BGP. So let's begin. So we'll discuss the BGP fundamentals and route advertisement, and we'll have the in-depth exploration of border gateway protocol essentials. We have to understand what is the importance of the BGP, why BGP is so dominant in the market today, because it is a core protocol that enables different ACE or autonomous systems to exchange routing information on the internet. And as you know that there are other protocols like the say the EIGRP, say the OSPF, say the routing information protocol, the RIP, but these are not used in the case of the internet. Because you know why? Because the internet has a millions of routes, and these protocols are not capable of exchanging all those routing prefixes. So it is the internet backbone protocol. It is used in the core layer of the internet, and its role in maintaining the stability and functionality of global internet routing cannot be overstated, because everywhere in the world you see every router, it has this border gateway protocol now, and it actually handles over 40 million routes nowadays, and it facilitates efficient data transmission across various paths. Now, what is BGP? BGP facilitates the interconnection of different autonomous systems on the internet. So internet is divided in different ACE or autonomous system. Yes, it is ACE in the internal network as well as in the enterprise network, also in the internet backbone. And it enables them to share routing information effectively. So it is a core component of internet communication. Also, it is a standardized protocol for all the internet backbone communication, and BGP ensures consistent routing policies and behaviors across different networks, and it helps to maintain a stable and efficient internet. And it is widely adopted due to its scalability, flexibility, because everywhere you can see the BGP protocol. There is one another protocol like the ISIS protocol that is closer to this BGP, but BGP is more standardized. It is more, you can say, the vendor neutral approach. It uses a path vector mechanism. But what do you mean by this? We know in case of RIP, that is a distance vector, pure distance vector protocol uses hop count to calculate the base route. What is the metric of EIGRP? It is bandwidth and delay. What is the metric of OSPF? It is cost. What is the metric of BGP? It is not a single metric. It has a several path vectors. Several vector means several metrics. BGP primarily uses a path vector mechanism to maintain the path information that gets updated dynamically as of any dynamic routing protocol when the network topology changes. This allows BGP to effectively prevent routing loops and ensure the convergence very fast. Definitely, it uses some mechanisms to ensure that there is a loop-free network, like it uses the split horizon rule, it uses, say, the router ID, and it uses the dynamic updates also to enable the loop-free environment. Now, it has some features like the policy-based routing. Now, BGP enables network operators to implement the routing policies based on the organizational needs. So, there is a specific term for the policy-based routing where you can manipulate the routing decisions, like the router makes not the destination-based routing, but it chooses the source-based routing, because everywhere in normal cases, router does the destination-based routing. It looks for the destination network. It never looks for the source network. But here you can change it. So BGP supports that thing, that policy-based routing, and it ensures that traffic flows according to the rules that I was telling you. Then the reliable transport via TCP. So it uses the TCP protocol, and definitely reliable transport mechanism is using the TCP protocol, and the routing updates are delivered accurately. Then multiple path exchange. BGP facilitates the exchange of routing information across the multiple paths, and it is like the other protocols also, like it does the load balancing, like the say the EIGRP or the OSPF, and it enhances redundancy and load sharing capabilities across different rules to the same destination. Then BGP architecture over time, it has changed a bit. Initial development or deployment, when was it? It was in the late 1980s to replace the earlier EGP protocol, exterior gateway protocol. Nowadays, we do not have the EGP anymore. Nowadays, we have BGP, initiating its role in internet routing. Then the standardization came in 1994, BGP version 4. BGP 4 was standardized by the IETF, Internet Engineering Task Force, that is, introducing support for CIDR, that is classless interdomain routing. Nowadays, we take the CIDR value, that is the blocks of CIDR address that is generated by the ISP that we know. That was introduced in the BGP because the internet, say the internet service providers, they are purchasing the CIDR blocks of addresses from the internet backbone, say the ICANN or the INA. Current state today BGP architecture includes multiple enhancements such as route reflectors. That is one way to avoid the loop in the IBGP, and configurations also for scalability in complex networks. So it has come a long way and it has incorporated many features here. Now, in case of the BGP route advertisement, what do we mean by that? It is essential for network communication when you are actually exchanging the routes with, say, other internet routers or internet backbone routers. It is very important because the network layer reachability, NLRI, that is exchanged with the other BGP peers. BGP route advertisement is essential for sharing routing information across different A's. So internet is divided into different A's, as we know, and BGP is responsible for sharing the information across the A's. And the process ensures that all participating networks are actually aware of available paths and making them suitable decision to actually reach the destination. And it includes key routing information also. Route advertisements include informations about the next hop address, as you know, because next hop, it is very important and crucial for BGP, because if the next hop is not reachable, definitely your update will not go and nothing will be achieved in the BGP. So next hop should be reachable. The AS path, like you are in the autonomous system 1 or 2, so where you are going, the AS path information, it should be in the routing update also, and it is a crucial factor to actually avoid the EBGP routing loop. And other attributes that help in determining the most efficient route, what are the other attributes? Like the weight, local preference, MED. These are different factors are there are a list of factors are there which is included in the BGP path selection, and this information is vital for optimizing data flow across the internet. Now, it uses update messages for announcements, BGP update. BGP uses the update message type to carry route advertisement, and this message informs peers of new routes or changes to existing routes. So, unlike the OSPA for the EIGRP, it is smarter and it is not having the LSA or the multicast updates, but it is having the update messages. Now it has open message, not only update, but the open message. The open message initiates a BGP session between two peers. So it is the first message, you can say, open message, and it has some certain also states BGP. And the open message is actually initiating a connection between the BGP neighbors or the BGP peers. And it allows them to establish parameters and capabilities for communication. This is the first stage of the communication. And then you have the update message. Now the update message is used to inform peers about new routes or changes. So it is actually like the LSU link state update in the OSP, if you can compare. It's like that update message, and it is informing peers about the new routes and facilitating the dynamic nature of route management, because if you have added some route, definitely it would be advertised to other peers. Now you have to understand the BGP path selection process also. This is very important and critical for determining the optimal route for data transmission, and definitely it evaluates multiple routing attributes because it is not dependent on a single attribute. Like you cannot say that bandwidth, delay, or anything like cost, reliability, MTU. No, this is not about the K5 values. These about the next hop, local preference, weight, MED. These are the factors that is there for the route selection. Then you first have the ACE path. Attribute lists the autonomous system that the route has traversed. So it provides a method for avoiding routing loops and for determining the shortest path to a destination. So if I am actually in the say ACE 1, so whenever I cross to some other ACE, the ACE path increases. And if you want to do some traffic engineering, say the route manipulation, then you have to increase the ACE path. And definitely the ACE path attribute will actually aid in that route selection. So if you're having say the longer ACE paths, so definitely the BGP will not send any data to that ACE path. So if you increment the ACE path attribute that way, so definitely the BGP is not going to consider that ACE path. Next hop, that is the very important part, because that I've already told you, next hop should be reachable. The next hop attribute indicates the IP address of the next router to which the packet should be forwarded, and next hop never changes in case of IBGP. In case of IBGP, there is a split horizon rule, and definitely what happens that whenever you send an update to the directly connected neighbor router, it doesn't change the next hop, and this is essential for ensuring packets reach their destination effectively. Now the local preference, this is also an attribute. It is used to select the preferred exit point for outbound traffic from an autonomous system. So there are some factors that is going to influence the inbound traffic that is coming from some, say, let's say other autonomous systems or other ISPs rather. And this local preference is going to actually influence the outbound traffic that is going towards ISP. Higher local preference values indicate more preferred routes, and it influences the path selection process. So you have to give the higher local preference, and it is exchanged between the say the ACE. So it is not only limited to a specific ACE like the weight. If you are considering the weight attribute, that is limited to a particular ACE only, but local preference is not. It is actually going to influence other ACE also. Then you have something that is for the filtering purpose, like in the OSPF or EIGRP. Also you have the prefix list. There in the EIGRP or OSPF we have the prefix list, we have the access list, we have the route maps. Here route map is used extensively in the BGP filtering, but along with it you have the prefix list that is simple and efficient, and it provides a simple way to filter routes based on specific IP address range. So you can give a CIDR value just like the EIGRP or OSPF, and it's a straightforward process to configure and efficient in terms of performance. So you can say that you can have a range of the IP address and you are having a CIDR value. So let's say the CIDR is /24, and you can have also a greater than equal to or less than equal to parameter also like the prefix list, that it should be greater than the 27 but not less than the 32. That the prefix list you can do. Also route map filtering, that it is available in EIGRP or OSPF, that is there in the BGP also, and it is a very robust mechanism. It is not like the ACL only, but it has multiple criteria. You can say add or say edit the routing metric also. So there are a lot of things available in the route maps, and route maps and policies are extensively used in the BGP. So in the ISP routing, the common use cases you have already, I've told you that ISPs use BGP in their backbone to manage the routing of data between their networks efficiently. So it is actually the preferred protocol for the ISP backbone. And then you have the multi-homing also. Then the multi-homing allows a single organization to connect to multiple ISPs. So it is not a single home connection. Like if you are having a single home, then you are having a single point of failure. If the one ISP that is connected to that is down, everything is gone. So you should have connection to multiple ISPs. So in BGP, definitely for the path selection, you are having multiple ISPs, and it provides redundancy and improved reliability in internet access. Now the BGP facilitates this by managing multiple connections. Then load balancing also is achieved. Means load balancing distributes network traffic across say multiple connections or servers. So definitely the BGP does the load balancing like the other protocols, and it optimizes performance and minimizes the downtime. and also BGP helps manage the distribution effectively. So you should have the effective strategies also for troubleshooting the BGP issues. Like the network administrators must systematically check configuration, ensure that the peer relationships are correctly established. So the peer relationship will not be established if you have given the wrong router ID. Say for example, if you haven't configured the router ID at all, so definitely the peer relationship will not be established. And I was telling you that next hop reachability you should check. Otherwise, there should be no relationship between the neighbors or the autonomous systems, I should say. So, what are the key takeaways from this BGP fundamentals that we have discussed? That we have covered the essential aspects of the border agreement protocol through this presentation. Also, we include the definition, key features, architecture, route advertisement process in detail, and also the message type, the open message, the update message, and its path solution methodology. And it is very crucial to understand the BGP for effective internet routing and network management. So this is about, you can say, the theory part for the BGP. And now I can take you to this GNS3 actually, because in the Cisco packet tracer level you will not find that BGP can be configured. So you have to say configure the BGP here, and here you just switch on the routers, and here you are connected to serial 1 by 0 to serial 1 by 0. So I'm just going to configure a simple BGP here network in the internal BGP process. So you can go to this serial 1 by 0 of this R1. If no shut, IP address say 1001, and you can give any subnet mask of your choice. I'm giving the default mask. And what you can do, you can also create a loopback. Loopback 0 and IP address maybe say 10001. Now you go to R2, and here also you are having the serial 1 by 0. Shut, and you give IP address as 192.168, say, or I think I have given there R1, I have given 1. So in that case you give here also not 192 but the 1002 and the default mask. And also you advertise loopback 0 there, like IP address is 20001 and the default mask. So I can have a IBGP pairing between this, say this R1 and R2, it is in the same network, but R3 is not. So go to config mode and router BGP, and see you have autonomous system number in the decimal as well as in the dotted decimal. So I'm not going for the dotted decimal now. I'm going for the BGP 1, that is the S number. Neighbor 1002, and the remote AS is 1. And also the network 1000, and you have 10000. And on R2 BGP 1, neighbor 1001, remote is 1, and network say 1.0.0.0. You do not need to have the subnet mask because you are using the default. Now if you change the subnet mask, then you have to write the network and the mask, and the network 20.0.0.0. Already the number is up, you can see. So if I now go to show IP route, you can see that the BGP route is coming. This is the BGP route. And also you can see show IP route BGP. So you can see that the BGP route is indeed there. And here also to show IP route, then BGP, then you can see that 20.0 the BGP route is very much there. So we have established the IBGP relationship between them. And you can also go to R3 now. And now this is the S1 by 1. So this S1 by 1, and the IP address say 2001, 2001, and this is the R3. Interface S1 by 1. I should verify once more the interface number. It is the R3. So it should be the IP address is 2002, let's say, for mask, and the interface loopback 0, IP address say 30001, this one, and here you are actually creating the serial 1 by 2. Say is 3001, and here in the R2 say serial 1 by 2, IP address 3002. So now we have configured the IP addresses. Now I can say that, let's say this R3 is in the different AS2. So it is 2001, 2002, 3001, 3002. So what you need to do, you have to go to the R1, router, then BGP 1, and you need to say neighbor 2002, and the remote AS, it is 2. And also you need to go to R3 and say router BGP and the number 2, and neighbor, let's say that is 2001, and the remote is 1. And you advertise the networks as well. That is, you are advertising the 2.0.0.0. You are advertising, say the 3.0.0.0, and you are advertising the 30.0.0.0, the loopback. So as you can see, the neighborship is up, and now it is 3001, 3002. So you are going to the R2, let's say, the BGP, and there is number 1, and you are pricing the neighbor, that is the 3001, and the remote AS is 2. And here in the R3, here you do here a neighbor, let's say neighbor is 3002, and the remote AS is 1. So we have established, yes, the neighbor is up, as you can see. And if I now see show IP route and the BGP, you can see the different routes are there, 1.0, 10, 20 different routes are coming. The eBGP as well as the IBGP routes are coming, and just see others like here do show IP route BGP. You can see again your here 2.0, 10.0, as well as 30.0 routes are coming. And in the R1 also, do show IP route, you can see all the routes are there. IP route BGP, I should say. Yes, you are having all the routes 3.0, 20.0, and 30.0 that is advertised. So this way, you can establish the BGP sessions, and also you can have the show IP BGP. There also you can see all the network preferences, like whether you are having the star. Star means this is a preferred path. This is star. The star means that it is a preferred path, like 10.0, it is advertised. Okay. And you can see that the preferred path for 20.00 it is 1002. So this is a preferred path to reach the specific networks. So it is a next hop. This is a routing table that you can read. So show IPVGP, and you can search for any destination and you can get the preferred path. You can see the local preferences, that is 100, and wait, that is by default 32768 for this internal routes. And paths, you can increase the path. So later you will do the path selection, and also you will increase the metrics of these routes. So this is how you can read the BGP routing table. I for the internal route that is there. So this is the internal routes that you can see. You can go to any other router also, do show IP BGP. So this is the BGP route. Show IP, that is a router's routing table, but this is the BGP's table, BGP routing table. And as you can see that these routes are visible in the BGP's routing table as well. So you can go to the R3 as well, show IP BGP, and you can see again the different factors, different parameters there in the BGP routing table. So this is a router's routing table, and this is a BGP's routing table. So if the next hop is not reachable, definitely in the show IP BGP, in the BGP's routing table, the route will not be entered. So that is also a very important factor in the BGP's route advertisement. So this is the way you have to configure the IBGP and EBGP sessions, and I have shown you in details how to configure these BGP sessions, also theoretically and practically. So I hope that you have understood it better, and it will be very helpful for your certifications for your CCNA, and as well as especially for CCNP, NRC, and ENCORE. So that is it about the BGP fundamentals and route advertisement for now. I will come with some other informations with BGP later. And I also have some contest for you. I will share a form with the questionnaire for you, and that you have to answer, and you have a very good opportunity for that, because if you can answer the minimum the 8 answers correctly on this topic, so definitely you can get a certificate for this, and everybody should avail this offer right now. So I'll be sharing this form very shortly, and definitely you just answer the questions. And these are very easy questions that is right from this webinar, and everybody should have this offer right now. So this is about the live webinar on the BGP fundamentals and route advertisements we have. And I have described every points and every topic theoretical and practical in details for you. And I think definitely it will be helpful for your studies, for the certification of the Cisco level, and also to get an immense understanding of the BGP protocol. And you can also implement it in your enterprise networking. So I thank you all again for watching and joining this webinar. And I'll come with some new topic very soon. Till then, keep studying, and bye.